Good morning, friends. Welcome to this session. In today's session, we will study the topic that is pneumatics. So, pneumatics, I will cover the lecture one. So, let us go to the syllabus. What is the syllabus of the pneumatics? So, in the pneumatics, first you have to study about the compressors, its types, then principle, working, and construction. Then we have to compare the pneumatic and hydraulic system. Then we have to study about the different components of pneumatic system. They are filters, pressure regulators, lubricators, mufflers, dryers, direction control valves, pneumatic actuators. Okay, then shuttle valve, pin pressure valve, quick exhaust valve, and time delay valves. Then we have to also study about the electro pneumatics. Then after this, we will discuss the circuits. So in the circuits, you have to study speed regulating methods, then pneumatic circuit, that is simple reciprocating circuit, then cascading time delay valve circuit and all, etc. Then lastly, we have to lastly in this syllabus is application of pneumatics in low cost automation and in industrial automation. Okay. So what are the in this syllabus? What are the theory part is there that we will cover now? Okay, and the circuit part is there that we will study later on. So if we come to the course outcome, it is to illustrate the components, control valves, and circuits of the pneumatic system. Okay, so we have to illustrate the components, control valves, and circuits of the pneumatic system. So, what are the learning outcome from this topic is that after studying the topic, we will be able to explain the meaning of pneumatics, what is pneumatics, then explain the advantage and disadvantage of compressed air, then we have to describe the various gas laws, then list the basic components required for pneumatic system, then compare the hydraulics and pneumatic system, then describe the working of various compressors, then list the advantage and disadvantage of compressors, then compare the types of compressor. Okay, so all these are the learning outcomes of this particular lecture. So let us begin with the pneumatics. What is pneumatics? So uh, from the Greek word it comes, that is pneuma. Okay, pneuma means what? It is to breathe. Okay, it is to breathe or air. So in Greek we call air. Okay, so normally what is happening in the pneumatics? Compressed air is used. Okay, compressed air is used. So just like water, gas, and electricity used in countless ways to benefit everyday life. Okay, so in the everyday life we are using water, gas, and all. Similarly, for the pneumatic system, we are using the compressed air. Okay, we are using the compressed air. So pneumatics is the application of compressed air, that is we call it as the pressurized air, to power machine or control or regulate machine. To control or regulating the machine, we are using the compressed air. Okay. So pneumatics, it can be also defined as the branch of fluid technology that deals with the generation, transmission, and control of power using the pressurized air. Okay. In pneumatic control, what happens? The compressed air is used as the working medium, normally at the pressure from 6 bar to 8 bar. So you can observe here that the what is the pressure range? The pressure range is very low here. That is 6 bar to 8 bar. Okay, then we will be using the pneumatic control. So using pneumatic control, maximum force up to 50 kilonewton can be developed. Okay, so using pneumatic, we can develop the maximum force up to 50 kilonewton. Okay, so next we will discuss about the choice of working medium and the system, how we are going to choice whether we have to select a pneumatic system. So when the system requirement is high speed, okay, when the system requirement is high speed and medium pressure, that is usually up to 6 to 8 bar, and less accuracy of position, is required, then pneumatic system is preferred. Then we will prefer the pneumatic system. So air is used where quick response of actuator is required. So then if the application requires only a medium pressure and high positional accuracy. So if we want the high positional accuracy, then we will use the hydro-pneumatic system. Then we will use the hydro-pneumatic system. So air, we know air is non-explosive. So it is preferred where fire and electrical hazard are expected. Okay. Then oils, we know that oils are more prone to the fire and electrical hazards. So they are not used in such applications. Okay, wherever the electrical hazards and fires are used, so there we will not use the hydraulic, that is oil. So air contains, what happens? Air contains about 20% oxygen, and it is not sufficient to provide the adequate lubrication of moving parts and seals. So oil is introduced into the airstream near the actuator to provide the lubrication. So this part we will discuss, that is the air, it is having some moisture. So so that again that lubrication, self lubrication of air is not done. So for that case, what we will use? We will use some oil for the lubrication. So since I said that we are compressed air is used in the pneumatic system, so let us see what are the advantages and disadvantages of compressed air. So advantage of compressed air is that air is available in unlimited quantities. Okay, so compressed air is easily conveyed in pipelines for the longer distance. Compressed air, it can be easily stored. So again, the compressed air is that it need not be returned. Okay, like in case of the hydraulic system, what was happening? Oil, after doing the work, it was returning to the tank. But here, compressed air, what will happen? The air will do the work, and then that compressed air will be released to the atmosphere. Then again, one more advantage is that compressed air is insensitive to temperature fluctuation. Okay, so again, in the extreme temperature condition, pneumatic system will work very smoothly. So if you see some disadvantage of compressed air, so compressed air is expensive, that is by means of conveying energy. The costs are higher. Okay, so they are the simpler and more compact equipment. Okay, compressed air requires the good conditioning. Compressed air requires the good conditioning. No dirt or moisture reduced residues may be contained in it. Then that means we have to clean the air, okay, and we have to remove the dust and dirt particles from the air. Then one of the disadvantages is that again it is not possible to achieve uniform and constant piston speeds. We can't achieve the constant speed piston speed because air is compressible. Again, compressed air is only economical up to certain force expenditure. That is, we are having the restriction that the compressed air will be used up to 7 bars, and the force limitation is up to 20 to 50 kilonewton. Okay, that is again depending upon the travel and the speed. So again, if the force exceeds about more than 50 kilonewton, then we have to go for the hydraulic system. So in this way, we can see the different advantage and disadvantage. So we can go through this slide later on. So there are more advantages and disadvantages. Okay. So let us see what are the difference between the hydraulic system and the pneumatic system. Okay. So main difference is that in pneumatics we are using air and which is compressible, and in hydraulics we are using the liquids such as oils which are not compressible. Okay, so pneumatic system, what we use the compressed gas such as air or nitrogen. Okay, maximum we will be using air or nitrogen to perform the work process. Similarly, in hydraulic system, we are using the liquids such as oil and water. Water mostly we are not using, very less, hardly 1% or 5% you can say, but we are using oil to perform the work process. Okay, then pneumatic systems, they are the open system. That is the compressed air which is exhausted to the atmosphere after use. Hydraulic system, they are the closed system. Okay, that is recirculating the oil after use. So some applications of pneumatics we see like in the clamping you can use. Okay, clamping, shifting, positioning. Okay, so all these are the part of the material handling. In the material handling, we can see there are many applications of the pneumatics. Like again in the packaging industry, you can see. Okay, then feeding, braking, ejection, that is injection molding machine and all we can use. Then manufacturing, drilling, simple drilling operation, then turning, milling. Okay, so here that is mainly in the quality control we will use. So some of the other applications are like that in the aircraft, then chemical plants, cement plants, coal mines, okay, machine tools. All these are the applications of the pneumatics. So apart from this, there are many n number of applications. Okay, so these are some applications I have discussed here. So let us go to the pneumatic system, that is components of the pneumatic system. Okay, what are the components of the pneumatic system? So here if you see the components, first part is the compressed air generation. Okay, compressed air generation. So here comes the compressor. So compressor, it will be run by the that is IC engine or the electrical motor. So normally compressor will be run by the electrical motor. So from the compressor, the compressed air is generated. Then we are having the second stage, that is the air storage section. Okay, in some of the cases we need to store the compressed air. Okay, so there we will use the tank, air tank, air tank for the air storage. Then cleaning section, air cleaning section. So this is I am talking about the air cleaning section. It contains about the filter, then dryer and the mist separator. Okay. So normally, what are the air which is coming from the atmosphere? So it will not be clean. So first, what we have to do, we have to clean the compressed air in the air cleaning section. Then air conditioning section is that here. This is the very important because here we will be using the filter, regulator, and the lubricator. So cleaned air, what again? It will be filtered. Okay. Then again it will be regulated and it will be lubricated. Then controlling section involves the direction control wall. Okay, in addition to direction control wall, I can also use the flow control wall to control the speed. Then last one is the operating section. It is where the actuator is used. So actuator, it performs the work. Actuator, it performs the work. Okay, so these are the uh, uh, components of the pneumatic system. Okay, so in the next in the next topic, what we will do, we will be discussing about the all these components. Okay. Then what are the advantages of pneumatic system? So due to the low inertia effect, pneumatic components, pneumatic system, they are having the low inertia effect. Okay, low inertia effect. Why? Because of the low density of air. Low density of air. Okay. Then pneumatic systems are light in weight. They are light in weight. Then the operating elements are cheaper and easy to operate. Why? Because hydraulic system, they are operating for the higher ranges. So again, you can see the component, their strength will be high, their material cost will be higher. But here the material cost will be less as compared to the hydraulic system. Then power losses are the less due to low viscosity of air. Then high output to weight ratio. So this is one of the good advantage. Then pneumatic system offers the safe power source in explosive environment. In explosive environment, again leakage is less. Leakage is less, and it does not influence the system. It does not influence the system. So so leakage is not harmful here in case of the pneumatic system. So these are the some advantages of the pneumatic system. Then if you see the disadvantages, in the disadvantages what happens? It is only suitable for the low pressure, okay, and low force application. And compressed air actuators are economical only up to 50 kilonewton force only. Okay, if the force is more than 50 kilonewton, you have to go for hydraulic system. So generation of the compressed air is expensive as compared to the electricity. Generation of the compressed, because we have to generate the compressed air directly. We can't use the atmospheric air. So that compressed air generation is there. That is expensive. So here what happens? Exhaust air. We are releasing the air to the atmosphere. That means some noise will be there. And this noise is unpleasant. So silencer has to be used. Silencer has to be used. Okay, silencer has to be used. Then here the rigidity of the system is poor. Rigidity of the system is poor. Then weight to pressure ratio is large. Weight to pressure ratio is large. So they are the less precise pneumatic system. That means they can't achieve the uniform speed due to compressibility of the air. Uniform speed can't be obtained in case of the pneumatic system. Again, pneumatic systems, they are vulnerable to dirt and contamination. Okay, so they contain dirt and contaminations. So let us discuss about the comparison between hydraulics and pneumatic system. So in the comparison, hydraulic system, we know that we are using the pressurized liquid as the fluid. Okay, pressurized liquid as the fluid, and here we are using as the compressed gas. Then oil, that is oil hydraulics, it will operate up to 700 bar, but here pneumatics only 5 to 10 bars we are using. So hydraulics is used for the closed system. Okay, their hydraulics open system is not used. So pneumatic system, they are used for the design for the open system. Here what happens in the hydraulic system, due to leakage, the system will get slow down. But here pneumatics, leakage does not affect. Okay. In hydraulics, wall operations are difficult. So pneumatics easy to operate the walls. One more heavier in weight. Hydraulic systems are heavier in weight. These are lighter in weight. Then here we are using the pumps. Okay, pumps for hydraulic system. Then pneumatics we are using the compressor. Okay, so here the system, the hydraulic system is unsafe to fire hazards. So here system is free from fire hazards. Okay, so here hydraulic system automatic lubrication is done. Okay, but pneumatics, we need the special arrangements for the lubrication. We need special lubrication. So these are some of the points I have discussed. So still there are more points, so we can go through. Before studying that compressor, we will see some of the properties of air. So air, we know that it is the mixture of gases containing by the volume. So approximately 78% of nitrogen is there, and 21% of oxygen, and about 1% of the other gases, including argon and carbon dioxide. So that's why you can say that in the pneumatics, air is used. Okay, and second gas, the gas we are using is the nitrogen. Some of the times, nitrogen will be used. So again, air is colorless, odorless, tasteless, and compressible. Air has some weight. So if we see some of the properties of air, what is its molecular weight? It is 28.96 kg per kilomole. Then density of air at 15 degrees Celsius and 1 bar, it is 1.21 kg per meter cube. Then boiling point, freezing point, and the gas control. So these are some of the properties of the air. So we know this how atmospheric air gauge pressure and absolute pressure are classified. That is absolute pressure is equal to what? Gauge pressure plus atmospheric pressure. Okay. When the gauge pressure is there, okay. When the vacuum pressure is there, that time the absolute pressure will be equal to atmospheric pressure minus vacuum pressure. Okay. So Boyle's law, we know what is Boyle's law. Boyle's law, it states that the pressure is inversely proportional to the volume when temperature is constant. Okay. So this means volume half, that means pressure will double. So here Boyle's law, temperature is constant. Again the Charles law, when the pressure is equal to constant, volume is directly proportional to the temperature. This means what? If volume increases, temperature will also increase. Okay, Gale-Lussac's law, what happens here? When the volume is constant, the pressure is directly proportional to the temperature. Okay, for state 1 and 2, we can say that P1 by T1 is equal to P2 by T2. This means that if the pressure increases, temperature will also increase. And if the pressure decreases,